electronic sprinklers webinar presented by Johnson Controls. We were having Dennis Phillips, the Business Development Manager, giving an overview, and then we'll be followed up by Gaurav Malik, Global Product Manager. Thank you, Dennis.
Okay, thanks everybody for jumping back in. I'll just start at the beginning again. So we're going to go through what is now actually the first electronically controlled fire sprinkler that has been UL listed. I'll go through part of the presentation, and then Gaurav will follow up with the owner's portion. And let me get my screen to move. Okay. What we're going to go through today is on the agenda is we're going to go through just some brief background history on the history of the innovation itself and the history of the fire sprinkler industry. We'll touch on the product overview and some application overviews. Gaurav will handle from the owner's perspective what you will see and the opportunity for some pilot programs that we are currently seeking. We'll follow that up with a question and answer period. So let's go through the background of the history of the innovation. If we look back 100 years ago, we look at what fire trucks were back at the turn of the century. I say turn of the century, 1900s, when you were dealing with a horse-drawn carriage with a water tank on it. That's how sprinklers or firefighting was done back in those periods. Where we look at today's modern firefighting, we are dealing with massive fire trucks built on fire pumps, capabilities of really fighting these fires, which is a far from what happened over 100 years ago. Then we turn and we look at how sprinklers were actually manufactured. This is a rendering from the facility of soldering sprinklers in Providence, Rhode Island, where sprinklers were first developed in that area, where everything was handmade. They were hand cast, they were hand soldered, whereas in today's modern fire protection manufacturing, the majority of all sprinklers are now manufactured through machinery. They are tested through their machinery. The glass balls and all those items are actually manufactured by equipment. Very little human contact with them. So then we look at fire sprinklers themselves, and if you look at the screen, you'll see two sprinklers. On the left-hand side was a circa 1900 sprinkler, and on the right-hand side, it's 2000 sprinklers. Basically, if you look at the sprinklers, nothing has changed in 100 years. We manufacture solder-type sprinklers by hand still. They're all custom to, all the linking and everything inside of it's done. It's soldered. You got the buttons. So we really haven't thought through the process of how to make sprinklers better. Although we've done a great job with things, we feel like there's a long way to go into making fire protection better. Again, a quick history for those who may not be aware. Henry Parmalee actually developed the first automatic sprinkler in 1874. But it wasn't until 1882 when Frederick Grinnell actually modernized what we call today's sprinklers. It was a solder seat linked in place. And then if you look to the far right-hand side, that is a 2000 model of the Tyco extended coverage 25 orifice. It's a 1-inch thread. It's used in storage applications. But in all these cases, you're relying on thermal activity of those elements to operate. So what we want to do is I wanted to go through an overview of where the technology is now heading with this first release of an electronic sprinkler. In order to understand that, we got to look at, generally how traditional sprinkler systems work, especially the thermal operated one. It's not necessarily where the sprinkler is located in relevance to the fire. It is where the heat plume is that activates the sprinkler. So if you've got a facility that's 40 or 50 foot tall, or even 20 foot tall with an airflow through it, like a large fan or something, that is actually going to change the operation of which sprinkler head will be affected, because you're waiting for the heat to activate that thermal sensor element, whereas, you're looking for the jets and the fire plume. So the fire could actually be 15 feet from where the first sprinkler activates is. So we're trying to work on, and we have worked on, creating an application where we can detect that fire sooner through electronics and be more accurate with what we're doing. And the reason that's important is because the faster you can detect a sprinkler, the bigger the impact you're going to have on the fire. If you can catch that sprinkler at an earlier rate, you're more than likely going to have a 60% smaller fire through earlier detection, as opposed to a thermal fixed temperature sensor. If you can pick up that rate of rise temperature change across that area, you're going to be able to detect that change very quickly, thus activating the heads that you want to, extinguishing that fire before it gets extremely large. If you're waiting for a fixed temperature, especially if you're in a large facility, you're going to be 40, 45 foot in storage, for that fire to build up through that racking system to get up to that temperature and across that ceiling in that T fashion, it's going to take a while. And so you're more than likely going to activate more sprinklers than you normally would want to activate. So we have a video that's going to show the activation through electronics on the left-hand side versus the application where a thermal sensing element activates a sprinkler. And it's pretty amazing to see the difference when you put electronics. On the left-hand side, you're dealing with a rate of rise detection mechanism. And so it's going to detect normally about a 20-degree temperature change from ambient. So what it's going to do, when it reaches that point, the thermal electronics are going to tell that sprinkler to actuate. So in 26 seconds, we have actually actuated the sprinkler over this test pan. So we've set our baseline to an understanding of what's really going to occur through the electronics, how much more efficient we can be in our firefighting applications. And as we let this fire on the right-hand side burn out, you're probably going to get around that, there you go, 72 seconds, where that head actually activates through thermals. So what we were able to prove in this application is that through electronics, we're going to have roughly a 65% time reduction in the activation of your sprinklers. And where this really shows up, and it's very interesting, is if you look at the thermal profile, the far left-hand picture, in 37 seconds, you can see you have very little red inside of all that dark blue. This is done through thermal imaging. If you take that 37 seconds, you go to the extreme for a traditional sprinkler at 48 seconds, you look at the heat release in that 10, 9-second range or 11-second range, the heat release difference when you're dealing with these exposed expanded plastics. In our application, we're going to probably be activating, in almost every case, 9 sprinklers through electronics and panel writing process. You're going to be at about 41 seconds, still well within that heat release that you're trying to pick up. So what if your sprinklers could really think, and suppose to letting just the heat itself, when you look at traditional sprinklers, there's no control over when and where what sprinklers are going to operate. About 80% of your water discharge is what we would call wasted water. That meaning that the water may be in fire sprinklers outside of the area of actual fire. In delayed activations, you actually have a lot of phenomenons called skipping of sprinklers. You may have an application where there could be a fire dead center of that fire plume that never actuates because of the way the heat transfer is at that ceiling. It may come up and bank before it ever really gets to the thermal sensing element. So only the electronic sprinklers are fired through activations. We can actually tell which sprinklers to activate, which allows us to use 100% water efficiency, as opposed to a situation where you may have sprinklers outside of your fire ring actuating. So to break down some of the parts, the way this application works is we're using an ESFR technology. The ESFR technology we selected was our ESFR K17 pendant sprinkler. That gave us, for this first application, the best use of water and pressures in facilities, or especially existing facilities, that need to upgrade their systems, who maybe are being requested to upgrade their system because a class commodity has changed. In the 80s, there was a lot of K14s put in for a class 3 commodity, but the fire officials are coming in now saying, okay, you're doing unexpanded or expanded plastics. Your sprinkler system is not up to the capabilities of protecting that. So we chose that ESFR technology because in those type facilities, you were dealing with a 3/4 inch thread where your sprinkler went into your pipe, and this same thread will work. So that sprinkler will actually be connected to a thermal sensor. Each sprinkler will have its own thermal sensor, and I don't know if I could do it on the screen. That sprinkler, you'll have a thermal sensor right above it, and then that thermal sensor through electronic is connected to the piece or on the sprinkler itself, what we call a metron. That metron is actually electronically fires the sprinklers that you dictate. So as that temperature raises in ambient temperature, your releasing panel, your addressable releasing panel knows where each detector is. It knows the temperature of each detector in your facility, or sensor, I should call it, is actually what it is. Each sensor in your facility. So when that sensors or series of sensors notice that temperature change, the algorithms in the panel will turn around and send a signal to 9 sprinklers in that area, discharging just the water over that area. Each sensor is addressable, so we know, like I said earlier, we know exactly where they are, and we can actually tell which sprinklers to release through the program that is written. So how does this compare? We have done some tests. We'd actually done a test of 40 foot of exposed expanded plastic under a 45-foot ceiling, utilizing 8-foot aisles, K25 ESFR sprinklers at 214 degree. And in this case, there was vertical barriers. That's what's required now when you start dealing with exposed expanded plastics in those cases. And as you can see, and that was the phenomenon I was talking about, if you look at the lower left, sprinkler number 3, which is not a fire area itself, never actuated. But yet you had sprinkler number 30 and 34 way off to the right, sprinkler number 12 at 1 minute and 35 seconds, actually actuating outside of the fire area. So we looked at that and we said, okay, we want to control this. But if you look on the right side of the slide, each one of the sprinklers inside of the ring, the 9 heads that we have picked, actually actuated all at 43 seconds. In the fire sprinkler world, you're basically creating a mini deluge system. You're allowing the fire to build, you're actuating, you're creating a deluge just over that control area. We did it all in 43 seconds with a K17. And if you look at the damage, when you look at the vertical barriers on the left, you'll see you had quite a bit of damage with a K25 and a lot of extra water wasted. We more efficiently, we got 15 feet tall into the burn. We actually extinguished the fire with a K17 sprinkler and 100% water usage. Okay, again, this is just the major benefits of the early grouping. Again, if you look at the left-hand side, that's a K25 sprinkler. So if you go to electronics, you're using less water pressure. You're using, you're going to have less water damage. You're going to have less residual damage on adjoining commodities from water damage because you're controlling that ring to where you want that actuation to be. So for an application overview, I just want to walk through this. So what you're going to be dealing with are performance-based hydraulics designs. For the first application that we're doing, we're going to do, or we have UL listings for a 35-foot building with 30 foot of exposed expanded Group A plastics using a 16.8 K factor sprinkler at 52 PSI. The minimum permissible hydraulics we're going to allow people to do will be 9 operating sprinklers, and we're going to calculate 4 sprinklers on each of 2 branch lines and 1 on a 3rd line, because we found through testing that in no case did we ever pass a length of branch line more than 4 sprinklers, which is really good, and we're only going to do 60 minutes. So that's how we're going to set up our criteria. What's really interesting is, although we've only tested the 35 foot of building, 30 foot of storage, that's for the sprinkler. If you were to take the electronic, because it has a 3-foot tether on it that runs from the metron to the sensor, electronic sensor, there's going to be cases where you may have a 36 or 37 foot tall building, which would still fall inside of this envelope. just because of the sheer fact that electronics can be placed above where the sprinkler testing was done. And here's the real advantage I found dealing with some owners and some applications is if you were to look even at a K14 sprinkler, so the K14 is the far left side, an older K14 sprinkler required roughly 1,455 gallons of water demand if you calculated the 4 heads on 3 lines as required by NFPA. If you use electronics, you're only going to use 1,090 gallons, and you're going to use it all efficiently. So if you have applications where the building already has an ESFR system in it, but again, you want to increase your capabilities of what or who can store in that facility, in most cases, you'd probably be able to do it with your existing piping system, changing out the heads, putting in electronic sensors, running the electrical component to it, and not have to change out fire pumps or add additional water supply tanks or anything to your facilities. And this actually allows for up to exposed expanded plastics with no vertical barriers. If you had vertical barriers or wanted to keep vertical barriers and go to a K25, which is a prescriptive code by NFPA 13, you can do that, but you're going to flow double the water requirements that you would normally have. And with that, I am going to turn it over to Gaurav.
Thank you, Dennis. Good afternoon, everyone. So I'm going to help summarize the information Dennis just talked about. We're going to look at this more from an owner's perspective, review some of the pain points and challenges you deal with, and then how the electronic sprinkler system can help to not only get around some of these challenges, but also help to really create a strategic advantage for engineers and users and warehouse owners. So let's get into it. Okay, so let's talk about some of the pain points. Now, as we just saw, sprinkler systems are designed with a safety factor in mind. So in the event of a fire, there's a phenomenon that occurs, it's called sprinkler skipping. And what that really means is sprinkler heads that you want going off may not necessarily operate just because of the way the fire plume behaves. And there's really no way to control which heads go off. And hence, you know, just to sort of account for that, you have 12 or 16 head designs, for example, in a ceiling-only ESFR system, and hence you end up using or requiring a lot more water and infrastructure to support that. So, you know, going through the limits of today's automatic sprinkler system technology, you see you're limited in terms of what you can do in designing the building, in terms of what product you can store, how you were able to store it. So what ends up happening is you're limited in terms of operational flexibility within the facility. It also ends up impacting the way you store your product, of course, the way you package it, configuration, etc. Really hinders your way, hinders the flexibility within a warehouse, and then ultimately it ends up impacting the insurance costs and risk profile, you know, when you store products in your warehouse. So let me give you, again, just a quick roundup of what Dennis talked about. You know, as we see more complicated commodities being stored in warehouses, we see the amount of plastic content in these commodities is going up. And, you know, the sprinkler systems that we have today are really not designed to support that. Or you'll end up having a sprinkler system which requires a huge amount of infrastructure to support that. And these will end up being very costly and intrusive. So the electronic sprinkler system, when you look at that, it can really, you know, use water a lot more efficiently. So you use, you know, really half the amount of water as compared to the closest alternative in case of, say, an exposed expanded plastic scenario at 35 feet, and you're able to provide the same level of fire protection with the electronic sprinkler. There's really no need to change the pipes. So you can use the 3/4 inch thread size ESFR K17. That's a sprinkler that most of you guys are maybe familiar with. And really, in most cases, it means there's no new pumps or fire tanks, which can be a major cost driver in a retrofit scenario, which is really what we're trying to target at this point with the electronic sprinkler. So what you're able to do is minimize disruption to your existing warehouse and, of course, maximize the operational flexibility. So let me summarize the benefits. I'll mention this one last time. There's improved fire protection that you can get. So as we saw, there's quicker detection that we can do with with this system, and that leads to a faster activation time. And we're really able to minimize the fire, suppress it, and the smoke damage that happens also to your assets is minimized. And we do all of that using half the amount of water. And this is really a function of the early detection and activation that this is kind of a system can provide. There's also the greater operational flexibility that you're able to get. You don't need to worry about in-rack sprinklers. A system like this allows you to store increasingly complicated commodities. You're able to expand your product packaging options. So you're really sort of future-proofing your warehouse in a way. And, there's no barriers required as well. There's more flexibility with your racks. So from an architecture design standpoint, there's more flexibility there. And what you get, of course, is a lower total risk. And there's a reduced potential for direct and indirect property damage, as you can see from some of those fire tests we've conducted. The bottom line, and this is what I'd really like for you to take away from this, is integrated solutions like the electronic sprinkler system allow us to deliver fire protection compliance while maximizing the operational flexibility in a warehouse. So this is my last slide here, so almost at the end. So just quickly to recap, what we presented to you today was the world's first electronic sprinkler system. The application we're targeting today with this technology is warehouse sprinkler upgrades to address higher hazard. But as you can see with this technology, what we really want to try and do is expand upon it and do greater things in the future. So that's the application we're looking at for now. The design criteria is very performance-based. So if you're familiar with Quell, which is a solution we offer for cold storage fire protection, we have components which are UL listed, but the design criteria that strings them together is provided by us. We've conducted multiple fire tests, of course, and this data will be provided to you as you're working in a project, and we work with you to support these discussions, the fire marshal A at J, and we go from there. And really, like I said, the bigger concept here is surrounding and drowning the fire. So instead of having, sprinkler heads go off randomly, you're really looking at 9 sprinkler heads targeting the seat of the fire, and this is a lot more effective. And another thing to note also here is the product we have available is, in July 2017, we're making this available for pilot installations today. And we really want to work with you on this. So we're evaluating candidates to take part in an exclusive pilot program. If you're interested in hearing more about the program or really learning more about the technology, have questions, want to have a discussion about this, please get in touch with us, and we'd be happy to talk to you about this. So with that, I'd again like to thank you for your participation. We appreciate you joining us today on this webinar, and I'll hand it over to Anne for some questions from the audience.
Thank you, Gaurav. Thank you. And thank you, Dennis, for the presentation. We will now take questions, and please send in your questions in that question box in your panel, and we will address them. We do have a few questions to start off with. You had talked about the exposed expanded Group A plastic as a storage material in many warehouses. Are there any other applications outside of that exposed expanded Group A plastic that can be protected with these electronic sprinklers? You had mentioned, warehouse owners being able to expand what they can store. So any other applications that you are aware of?
Yes, and Gaurav, I'll answer this if you don't mind. There's applications. I mean, exposed expanded plastics is the highest application. If it's less than that, as set up by NFPA standards, then you could still do those applications. We are getting fielded some questions from owners and other people talking about possibly lithium ion, solid fuels, other applications, and knowing that this is going to be a performance-based design or has that technology component by it as allowed by NFPA, there's nothing that's really off the table if an owner has a system that he wants to discuss, I think we're more than open to have that conversation. And that's where we have to be very supportive to them for what they're trying to protect, how they're trying to protect, the authorities having jurisdiction, making sure the right people are involved in that conversation if it gets outside of what's originally tested. But yes, everything's on the table at this point.
Thank you. And you had also talked about one of the examples you had shown, Dennis and Gaurav, that you had followed up on was you showed us those examples of the plastics being stored up to 30 feet under a 35-foot ceiling. What if, of course, some of our listeners and others have a scenario outside of this, higher ceiling heights maybe than 35? What are your findings or on that thus far for this?
Want to answer that, Gaurav?
Sure. So, again, like Dennis also mentioned, this is a performance-based design. And with the testing we've conducted at UL, we've conducted 12 full-scale fire tests. The application we're targeting today is 35-foot ceiling heights, 30-foot of storage with exposed expanded plastics. If it's anything outside of that, we'd like to have that discussion with you. It is possible, depending on what that application is, that we may be able to support it. But again, we'd like to have that conversation with you. We'd like to understand what commodities you'd like to protect, what the challenges are, the hazards are you're looking at, and we can work on that together.
Thank you. And let's see, and one more question. You had talked about the retrofit marking. I believe Gaurav, you had mentioned the retrofit market being a big focus, and I guess also a new builds. But in terms of retrofit and people that are listening, I would imagine most of them have existing warehouses already. So can you talk about, either of you, the general overview of what a retrofit might be, what that might entail?
Yeah, I can answer that one. So a retrofit, and from my background, what I would call the 1980s, early 90s model ESFR K14 buildings. Prior, to about 95 or so, most people built their buildings under 35 foot of height. They were storing class 3, class 4 commodities, and back in those time periods, an ESFR 14 was the only sprinkler head available. But as commodity classes have increased, more plastics and expanded plastics and how we store and arrange things, those heads we're finding are not as efficient or may not actually get you what you expected in your fire applications. So AHJs have now taken it upon themselves to look when you start changing your storage arrangements and stuff to make sure that the systems are there. So in those cases, it may be as simple as unscrewing the sprinkler heads are there, put this new head in, add the electronic components, and the piping and everything that's already there will still be sufficient. I mean, you won't have, in a retrofit, you may not have to change out your mains or branch lines or your fire pumps or your water storage. So in those applications, it's a really good fit. There may be, and that's when we would do evaluations with people on, what pipe was already there, pieces and components that were in place where you may or may not have to do anything more than change out sprinkler heads. So that's when we're talking about the retrofit. And like I found out is that early 80s to mid 90s existing warehouses were really seem to be a prime location for this one.
Thank you. Okay, we do have another question. If you could talk about what is the cost or per head for the electronic detection. I don't know if that's how you how you discuss it in terms of cost per head, but there was a question about that. And additionally, can this be used on a dry system as well? And do the heat detectors need annual calibration?
Okay, so let me go through all. Okay, that's one question. Okay, it has not been currently tested on dry systems because there are no dry ESFR systems or other systems out there because of the standard itself does not allow for ESFR systems to be dry. So if you had a dry system out there, you would most likely have to convert to wet. But again, maybe future testing would allow for that. What were the other parts of the question? I missed it.
The attendee asks that will the heat detectors I don't know if that's the sensors, will need annual calibration by a third-party contractor or another party?
Okay,
Calibration question.
Yeah. So the sensors, right now, the intent is not to have them calibrated. Those are the conversations we've had with UL and other insurers. Is it's not a heat detector; it's a sensor, much like you would a sprinkler, glass bulb, or a linking element. You don't check your sprinkler heads every year and check the thermal sensitivity of those. So the approval process or the listing process is going to be that it is a sensor. Now, those are conversations that AHJs are going to want to get involved in as well. They're going to try and call it a detector and try to push for an NFPA 72 annual heat test. But those are the ones we would have that conversation with them and saying, no, it's no different than your link element in your sprinkler. So that's where we're going. So I would say at this point, we're pushing to not have to do that every year.
Thank you. Okay, and let's see, we have one last question, unless another comes in. Are there plans to get your this system, this equipment, FM approved? Have you had any discussions with them?
To answer that question, yes. When? I don't know, but the conversations will take place or have begun to take place with Factory Mutual. So yes, it will eventually at some point hope to get Factory Mutual approval. That is an ongoing process with Factory Mutual. And I don't know if it's a year or 3 years. I don't know what all the test protocol is at this point that FM's going to want to go through, but those are conversations that are being had.
Wonderful, thank you. And I thank you, Dennis and Gaurav, for the presentation. It looks like that's all the questions we have right now. We will also encourage our attendees to, of course, contact you if they would like to take part or learn more about the pilot programs that you're doing. So thank you again, Dennis and Gaurav, and to Johnson Controls for sponsoring this webinar, and of course to our audience for attending and for sending your questions. A recording of this webinar will be available online at facilityexecutive.com, as well as on the Johnson Controls website. And I'd just like to add a final note. Don't forget to check out our Facility Executive Live Conference hosted by our magazine. That takes place October 3rd in Chicago. You can check it out at facilityexecutive.com. Thank you again, everyone. Have a great afternoon.